Alright, this is a quick video post my adventures in trying to bake ambient occlusion maps. Long story short, we are running the lightweight render pipeline in Unity 2018.4.12 F1, and at the time of this recording, the ambient occlusion post-processing real-time effect is not available for LWRP, or rather, while you can add it to your post-processing volume, it doesn't do anything, and post-processing or rather ambient occlusion is a huge way of making your game look nicer, so I've been looking at other ways to do that. One of the ways that you can do it is by baking ambient occlusion maps in external programs, and I just want to make this video for anybody looking to do that, right? So I have this model right here, and before I actually show off how we baked it, all I'm going to show you is that I did end up with this occlusion map right here, and I went ahead and equipped it, and if we turn it on, you'll see that it does darken things, but it's seemingly darkening everything. And if we turn off the lighting, you'll be able to see that it does seem like it's darkening pretty much everything here. And there are some faces which are just arbitrarily not getting darkened. It's kind of weird, right? Like it's just kind of choosing which faces it's darkening. So that'll lead me to my first point when it comes to doing this, which is that you have to be very careful with UVs. So if we go ahead and go into Maya, I'm going to now generate the occlusion map for this building right here, called Spiral. You can see that right now there's no occlusion. It's pretty flat on the sides. So I've gone ahead and I've imported the FBX for this building into Maya. And what we're going to do is that first of all, we're going to go ahead and check out the UVs. So if I click on it, object mode, and we go to UV editor, you'll see that the UVs are set up like this for me. If they are not set up like this for you, and in fact, I think I can show you it without it set up like that if I re-import this model. So let's go back and do that properly. Let's take this spiral building and import it in. If we go to UV editor, yeah, you'll see how all of the UVs are stacked on top of each other, right? We don't want that. That'll mess up our ambient occlusion like we saw with the other one. So the way to fix that, so that it's not like this and it's rather spread out like we saw before, is that you go under UV and you hit automatic, or you manually do your UVs if you want to. And that's going to have Maya generate the UVs for you. So if we go back into UV editor, you'll see that it's all nicely laid out now, right? So what we can do now is we can go ahead and right click on our object and go to assign new material. Well, first of all, I'm going to save this FBX. Now that we've gone ahead and fixed this UV, I'm going to save this FBX, import it back into Unity. There we go. That's right here. Nothing has changed. Cool. Now that we've fixed the UV, I'm going to go ahead and right click on this and hit assign new material. And I'm going to go down to Arnold and I'm going to hit AI ambient occlusion. Right, that's going to assign this new material. And what this is going to allow us to do is that if we go ahead and go into Arnold and then render, we're going to go ahead and see that it's actually rendering the actual ambient occlusion, which is basically just a black and white map in which the corners and sharp edges are rendered as darker, meanwhile the flat faces are rendered as lighter. So what that basically ends up doing is that anywhere that there's a corner where light would normally not get into, you get this sort of shadow effect, which is quite cool. Right. So, and then you can go ahead and mess around with the settings in here if you want. There's things that you can do to minimize the white or minimize the darkness. You can turn the samples up, which will greatly increase your render time in this setting, but will make it less noisy. I'm going to go ahead and just set mine to 5 for now. And this is just giving us a preview of what it's going to look like. Right. So let's say that we're satisfied with that. We pretty much should be. There's nothing really to mess around with here too much. We're going to go back into Arnold and then with our model selected, go to utilities and then render selection to texture. We click on that. We go ahead and set a folder where it's going to export to. I just have this temporary folder that I made. Resolution 512 is a little low. If you want a good result, you're going to go for 1024, maybe 2048. Given that these models that we're working with are low poly, honestly 512 would probably be fine. But for argument's sake, let's go ahead and do 1024 and make sure that we're selected on our building. You can keep most of these settings the same, but you can feel free to mess around with them if you'd like. And then hit render. And you're going to see that it's going to take a second. You can see the progress bar at the bottom right, or bottom left here rather. Because we put 1024, it does take twice as long as if we had left it on 512. And what it's essentially doing is just that preview that I showed you earlier, that's just from one angle of the model, right? That's just applying the shader. It's now going over that UV and it's making an entire texture of that kind of thing. So now if I go into that folder that I just worked with, temp is here. you'll see that we now have a thing called spiral building 2 shape.exr. EXR is a very high definition file format. I can't even open it in like paint.net or something. You would need to use Photoshop, and I don't have that installed, so I can't show you it. But basically, trust me that all it looks like is this UV, but over each of these, there's just a black and white texture corresponding to whether this is supposed to be lighter or darker. So what we're going to do now is we're going to take this texture, and we're going to go into Unity, and we're going to import this in. So as soon as we drag it in, you'll see that Unity will recognize it as a texture, and we can see all that black and white goodness of it. And what we need to do now is go to the material for our building. Even if the building is multiple materials, whichever material you want to be affected by the ambient occlusion, you go to it and you'll see that there's a little occlusion tab right here, and we're going to go ahead and drag in our occlusion map. And you'll see that instantly that makes a huge difference. I'll go ahead and just toggle between 0 occlusion and 1 so you can see how different this looks. This is with 1, this is with 0, 1, 0. If we go ahead and turn off lighting, we can see it pretty well. It's hard to tell when you have it at 1, but as soon as you turn it to 0, it's pretty clear what it's doing. These corners are essentially being darkened to show that light would have a harder time getting in there. And then if we turn the lighting back on, you'll see how much of a massive effect this has in game. And we are getting some questionable reflections here, but that's probably because these windows have a different UV. I don't know if that's a reflection thing or if that's a UV thing. But that's something that you can mess around with as well, because the material for these windows that I have right here is actually different. It's this window blue material here. So if I duplicate this just for argument's sake, oops, not the whole folder. Duplicate this and stick it over here. We'll put that under window blue. Stick this under there. And then also give the occlusion map to this. Yeah, that doesn't do much for us on the actual windows because the windows are reflective, so it's not doing much. You really just care about the main structure of the building for an example like this. So this is likely a reflection thing because it thinks that the light can't get in there, so it's not reflecting it. But that's fine, honestly. So you can see how much of a huge impact occlusion culling can have, and because this is baked into the texture, it's not going to be generated in real time, which is also going to save you some processing power on the post-processing effect. And this means that it can be ran on the scriptable render pipelines that don't support it yet, which in this case is the lightweight render pipeline. And the reason why we are doing that in our game is because it has given us far better frame rate than the high definition render pipeline, and we also have use for the shader graph as well as VFX graph, both of which are currently only available in the scriptable render pipelines. So there you go. There's my solution for the lack of the ambient occlusion post-processing effect in the lightweight render pipeline.